In this first question, you can see that the first part of the question where you have to work out the PMCC, you're going to have to use summarized data, which means you have to refer to this formula, which is in your formula booklet. Make sure you use full accuracy and round off your final answer to the required level, which is 3 significant figures. For the second part of the question, interpret in context of the question. This is a set response. Have a look at it, please. Adjective, strong, weak, moderate, negative or positive correlation between X and Y. And with X and Y, you replace it with what X and Y stand for in the context of the question. In this second question, this is all done on your graphical calculator. For the first part of the question, where you need to work out things like the modal range, the modal value, the median and the interquartile range, you don't really need to know this last figure over here. So here you can input any value you like. For group frequency tables, you need for the rest of it to input the mid value, the midpoint. Also, please make sure that your setting on your calculator is set correctly. That changes, so make sure you're aware of what the settings are on your graphical calculator when you're doing either a frequency table or a list of numbers. The answers for the first part of this question, as you can see, are here. For the interquartile range, they wanted working out, showing the upper quartile, take away the lower quartile. Again, rounding for full answers. You'll often see this in a mark scheme. That is the range of values for standard deviation for which they'll accept full mark, for which you'll gain, full marks. To do the part B, obviously they told you now what the 50 or more was. So for that section, you can actually put in the correct value in that final row, and then you'll be able to calculate a proper mean and standard deviation. For the final part of the question, over here, if you have a quick look, you need to work out the average of both Royal Mail and the courier service. In order to do that successfully, you need to know the total, an estimate of the total number of letters distributed by the Royal Mail, which is this figure. That figure has been worked out using this. So in the previous part of the question, you've got an estimate of the mean, which is the total divided by n. So if I cross multiply, I'll get an estimate for the total, which is where I'm getting that number from, to give this final estimate of a mean over here. Most of this question is a straightforward question using your graphical calculator to calculate the least squares regression line. Make sure that's accurate, because you do need an accurate one to get the calculations correct later on in this question. So here we have the correct and acceptable range and rounding for your regression line, for the y-intercept and for the gradient. In order to draw the regression line on the graph paper they've provided for you, make sure you use at least 3 points or calculate 3 points using this regression line here in order to create 3 points through which your line will go. And the acceptable answers, obviously, for C part 2 lie in this range over here. For the final part of the question, where you're comparing the two regression lines, there are two key differences between the two. One of them could be about comparing how much salt dissolves for line A and line B at either low or high temperatures. The other is to do with the difference in the gradient between the two lines. This probability question, most of the part of the question will be done by using the data in the table. So for instance, if you want to work out the probability of exactly 3 bedrooms, it's out of 640 properties, and the number of properties which have exactly 3 bedrooms are all of these over here, and they've totaled them up for you anyway, so it's 194 out of 640. At least 2 toilets could mean either properties with 2 toilets, 3, 4 or more. So it's all of these out of 640. This conditional probability at the end, the probability of at most 3 bedrooms, given that has exactly 2 toilets, you can use you can do using the conditional probability formula or by making use of the table. If you're going to make use of the table, then you first need to identify only the properties that have exactly 2 toilets. So in other words, the probability is going to be out of 172. And then we're going to look for how many properties there are with at most 3 bedrooms amongst those 172 properties. So at most 3 bedrooms will be either 1 bedroom, 2 or 3. So all of these together, these 3 groupings out of 172 is the answer to this conditional probability in part 4. You can see for that second part of the question, they'll expect to see some working out as well as the final answer. Leave it as a fraction. If you do convert it to a decimal, make sure you round off correctly. And for this part also, and for the conditional probability. For the final 2 parts of the question, which are quite difficult, for the independent question, where you're trying to show whether 2 events are independent, you need to demonstrate this formula. So if they were independent, they would follow this formula. If you use the answers for A part 1, 2 and 3, you can see those 3 probabilities wouldn't follow that rule, and that demonstrates that the 2 events in the table are not independent. For the final part of the question, part C, where you have to work out the probability of a property having 2 toilets and 3 toilets and 4 or more, this calculation here is working out the probability of exactly that combination, i.e. the first property has 2 toilets and then the second has 3 and so on. But that could have happened in a number of different combinations. If you want to list them, you'll see there are 6. And each of those 6, even though it would have a separate calculation to it, would have the same total as this individual calculation here. So if you multiply this answer by 6, you'll get the answer to the actual probability question. This is a fairly standard sort of normal distribution question, and I'm going to show you the very bare minimum working out you need to demonstrate with a question like this. For the first part, I would strongly suggest you start by first writing out the distribution, the normal distribution on which your calculations are going to be based. This is the initial information represented obviously using inequality symbols and a clear diagram showing where the centre is at 2.75 and you're doing less than 2.8, which is going to give you an area obviously bigger than 50%. Then you do an equivalent Z diagram. Centre of a Z diagram is 0, standard deviation is 1, and again there'll be a point on the Z diagram equivalent to 2.8, which gives the same area. The relationship between 2.8 and that Z1 position on this diagram can be given by the standardizing formula. Z equals X, take away the mean, divided by standard deviation. The mean and the standard deviation refer to the mean and the standard deviation of the normal distribution. And that gives this value here. Your calculator will tell you this value as well. This is the Z number on this diagram equivalent to the 2.8. And then it's acceptable to write down this answer here. So the final probability answer, make sure you have clear rounding to an accurate level, otherwise you'll be in danger of losing a lot of marks. Going back to this main question over here, it's important you understand the difference between this part of the question and this part of the question. Here they talked about a random sample of 4 bags, and they're looking at all 4 bags having a particular probability. And we do it by working out the probability of an individual bag and then doing it to the power of 4. But in this part of the question, in part C, they're looking at a random sample, but then they're looking at the mean of that sample. And that's where you use the distribution of sample means as the basis of doing a question. So they both talk about a random sample. One will talk about the mean of a sample and one doesn't. and they're both dealt with using a very different approach and method. As you can see, for the second part over here, we've done the same. We're looking at W being bigger than 2.5. So over here, a clear diagram, Z diagram, trying to find this Z number equivalent to 2.5. That's done by this standardizing formula, which gives us this. This can be done on your calculator. Your calculator will also tell you the Z number. And it makes sense. We'd expect the Z number to be negative because it's on the left of 0. And then you can write down your final answer. For the third one, very similar. As you can see, this time we'll be finding two Z numbers which are equivalent to the 5.1 and the 5.3. Two different standardizing formulas. Both of them make sense. We'd expect this one to be negative and positive, and then your final answer rounded to the level of accuracy you need. For part 2, very simple. This is the probability that X falls between 5.1 and 5.3. So the probability it doesn't would be given in that range. And because we're looking at 4 of them in a row having that, we'll be doing that to the power 4. Going back to the last part, part C then. So part C is based on a distribution of sample means. So there's the original normal distribution. You'll notice they're talking about a different mean and a different standard deviation. So we're going to base it on a Y-bar diagram. In other words, a distribution of sample means which has the same mean, but so as you can see, the standard deviation is different. It's going to be the standard deviation of the parent population divided by the square root of n. In terms of a diagram, that's what we're being asked to work out on the Y-bar diagram. We're going to use a Z diagram, as you can see, to help us do that. So we'll still try and find the Z1 number equivalent to this number, done by the same standardizing formula, except here when you divide by the square root of n, this is your standard deviation there. And there's your final answer. This is your binomial distribution question, and again, it's important to notice a couple of things about this question. As often is the case, they may well change the probability or the number of trials as they go through the question and ask you to do different parts of it. And it's important you're aware of this. So in the first part of the question, as you'll see, the binomial is trials of 30, and there's the probability of success. And when they ask for an exact probability, we want to make sure we have the method mark, which is for using the appropriate formula before you write down your answer. This can be obtained from your calculator, but this is necessary for the method mark. As usual, I've started the question by clearly writing down the distribution and the parameters. In part 2, they've now changed the probability. They're counting a different success, two different colours. And again, I've written down their question using inequality symbols, greater than 10. How do I do it? If you're not sure, look at this on the side. This is a clear list. So greater than 10 will be 12, 13, all the way up to the end, which will be 30. The ones not included in that list would be from 0 to 10. So I can achieve that by doing this. There's my method. Then I'd write down the answer to this and then the final answer, which is there. You're going to in part 3 of the question, again, they've decided to change the probability of success. This time, if you read the language carefully, you're doing at most 10 and at least 5. Again, on the side of the page, I've ticked the ones that would include. It would only include 5 to 10 inclusive. I can achieve that by doing 10 and less, which will be all of these from 0 up to including 10, and take away the answers from 0 to 4, which is this method over here, which they give method marks for the numbers and then your final answer. To work out the mean and variance of a binomial distribution using formulas, which are in your formula booklet. Be aware here they don't want the variance, they want standard deviation, which is the square root of variance. For the final part of the question, you're comparing. Is a set response, as we've discussed before. You're going to compare the mean and the standard deviation. So you're going to discuss the mean and the standard deviation from the formula against the mean and standard deviation from a sample. In this example, they've already calculated that for you. In other questions, you'd be expected to calculate that as well. If the means are similar or the same, and the standard deviations are similar or the same, then the binomial model is valid. If there are differences, then the binomial model is not valid, and you would have to come up with reasons in context why that might be, looking at things like the independence of trials, it's a fixed number of trials, one trial does not affect another, in other words, and whether the probability P is fixed at a particular level. In this case, because they are similar, we're going to reject both claims and accept the original statements. This final question, this is a fairly standard question asking you to work out a confidence interval and making set responses as comments. In the first part, working out a confidence interval, be aware that you need a mean. The mean will be worked out from the sample using this standard formula over here, which is not in your formula booklet. Very simple and easy to remember. The standard deviation will be worked out either from the sample, or if it's given, then we're using the one from the parent population. But nevertheless, whichever one you pick, it will still need to be divided by the square root of n in order to calculate a confidence interval. Here, an added complication was conversion of units. One was given in litres, one was given in millilitres. So one needed to be converted into the other. Confidence intervals, again, we're finding the boundaries. There's the Z diagram, and this can be found on your calculator. So type in a Z diagram and look at a central area of 98% in this example, and those will be your Z numbers. Again, a standardizing formula will convert those Z numbers into X numbers, which are there and there, rounded off to a level of accuracy. As you can see, this is how we would ideally like you to write the confidence interval. Over here, make sure you're aware that when you're dividing by the standard deviation is the standard deviation divided by the square root of n. For the set responses, not too difficult. As usual, you'll be looking at two things probably. One is the confidence interval itself. So if you look at the first claim, we're likely to accept it because the confidence interval indicates that the mean is likely to be above 5 litres. However, if you were to look at the second claim can be inferred from the sample. So the sample will have some information in it against which you can judge the other claim they make, and in this case you can see we're going to reject it. For the final part of the question, did we need to make use of the central limit theorem? Yes, but you have to give a reason. And the only reason you need to ever make use of the central limit theorem is simple. It's because the parent population you're not told whether the parent population is normally distributed and the sample size is large. So in this case, we did make use of the central limit theorem, and it was valid to make use of it.